Hello everyone. Today see about the applications of Gyroscope Aerodynamics. Now, today see about the topic Gyroscope. The gyroscope has evolved from technologies like mechanical inertial spinning devices. These technologies include gimbals, rotors, axles, and other electronics, and also optical devices. Moreover, each of its components exploits some physical properties of the system. These properties enable it to delete the radiation velocity about some axis. Definition of a gyroscope. A gyroscope is a device that is made for having a disc. The spins or a wheel mounted on a base like its axis can turn freely in one or more than one direction. However, in order to maintain its orientation regardless of any kind of movement of the base, whereas the orientation changes in response to any external vacuum and in a direction differently. Design of a gyroscope. The gyroscope is a rotor that is fixed in a ring that supported light known as gimbals. The gimbals consist of some frictionless bearing that isolates the central rotor from the outside circuits. The axial presence in the spinning wheel defines the spin axis. The rotor possesses 3 degrees of rotational freedom and spins near about an axis as well. It gains some extraordinary stability of balance when at high speed. It is because it regulates the high speed rotational axis via its central rotors. Gyroscope working principle. When the application of the gyroscope takes place with an external vacuum or rotational about the given axis, the orientation is measurable by a precise phenomenon. When an object is rotating around an axis is applied with external vacuum along a perpendicular direction to the rotational axis. As a result of it, the precise vacuum. This rotation about the spin axis occurs and the information of the rotation transfers to a motor. It also delivers it to any other devices that applies the vacuum in an opposite direction. Thereby, it cancels the precise and maintain its orientation. Two devices prevent precession. These are set perpendicular to each other. The rotation rate is measurable by the pulsation of contracting vacuum at constant intervals of time. Uses of gyroscope. It comes in use as a compass of spacecraft and aeroplanes. In aeroplanes, the pitch and the orientation of the aeroplane are measurable against the steady spin of the gyroscope. In the spacecraft, the spinning center of the gyroscope comes in use as the point of orientation for helping in navigation the desired target. The massive ones are applicable in stabilizing large boats and some statelets. They are also usable in guidance system in some of the missiles. Other applications of gyroscope include an internal navigation system and gyroscopes for maintaining the direction in the mining of tunnels. Next, aerodynamics. The way objects move through air. The rule of aerodynamics explain how an aeroplane is able to fly. Anything that moves through air is affected by aerodynamics, from a rocket blasting off to a kite flying. Since they are surrounded by air, even cars are affected by aerodynamics. The four forces of flight are lift, weight, thrust, and drag. These forces make an object move up and or down, and faster or slower. The amount of each force compared to its opposing force determines how an object moves through the air. Thank you.